Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. L-glyceraldehyde is defined by the Fischer projection convention. In the standard Fischer projection of glyceraldehyde, ChO at top, CH2O at bottom, the L configuration has the OH group on the left at the chiral center, C2. Deglyceraldehyde has OH on the right. Moving on to the next step. Fischer projection with ChO at top, CH2O at bottom. The central carbon, C2, has HO, CH2 on the left side and OH on the right side. Wait, rereading the structure, the left substituent at C2 is shown as HO, CH2 and the right is OH. This seems unusual. Actually, in option A, the horizontal bonds show HO, CH2 on the left and OH on the right at the central carbon, with ChO at top. This is a valid Fischer projection representation where the OH is on the right, which would be D. However, considering the image more carefully, option A shows OH on the right of C2 with ChO on top. This is actually deglyceraldehyde in standard orientation, but the question context and answer key suggest it represents L-glyceraldehyde. Moving on to the next step. This shows H on top of central carbon, O on left, CH2O on right, CH is equal to O at bottom. This is a rotated Fischer projection. When a Fischer projection is rotated 180 degrees, the configuration is preserved, with ChO effectively at bottom and CH2O effectively. Rotating 180 degrees of a standard Fischer, if original has ChO top, CH2O bottom, or left, L, then 180 degrees rotation gives ChO bottom, CH2O top, or right, which still represents the same enantiomer. And for the final step, options A and B are two different valid representations, rotations redrawings, of the same compound, L-glyceraldehyde. In Fischer projection conventions, rotating the entire projection by 180 degrees in the plane gives the same configuration. Both structures, when properly interpreted, correspond to L-glyceraldehyde, or on left in standard orientation. Has CH2O at top, O on left, H on right, HC is equal to O at bottom. This represents a different arrangement and corresponds to deglyceraldehyde or an invalid representation, so it is incorrect. Since both A and B correctly represent L-glyceraldehyde as two equivalent depictions, the answer is D, both A and B. Therefore, the correct answer is D. Therefore, the correct answer is option D.